Okay, welcome. We'll get started now. Hello and welcome to our webinar, the Mirror Lab, RF Testing and RAN Deployment in the Telco Cloud Era. My name is Sonia and I am a marketing coordinator here at Acentury. Throughout the presentation, we encourage you to ask questions in the QA section and we'll go over some answers at the end. Now for a little introduction to Acentury. We help organizations test and deploy 3G, 4G, and 5G networks. Founded in 2011, Acentury is an RF engineering company developing hardware and software products for mobile network operators, cable MSOs, network equipment manufacturers, chipset manufacturers, and internet-scale tech companies. Now I'd like to introduce our speaker today, David Woodcock. He is product strategy at Acentury. He has over 30 years of experience in the wireless industry, with industry leaders such as Motorola, HTC, Dell, as well as several startups and scale-ups. He's had roles ranging from systems engineering and product management to sales and business development. He also has experience with hardware, software, and professional services. On to you, David.
Thank you, Sonia. It's always weird to hear that said out loud because it contradicts the view in my head that I'm still a 20-year-old engineering co-op student. So welcome everyone and thank you for taking some time out of your day to join us. As Sonia delicately pointed out, I've been in the industry for a while. I've been with Acentury now for a couple of years. I have some sales responsibilities, but I'm also involved with the product strategy as well. And it's in that capacity that I'm speaking with you today. Here's what we're going to cover in the next 30 or 40 minutes or so. First, we're going to talk about some of the challenges created by the recent trend of migrating telco networks to the cloud, particularly around testing. Next, we'll compare the traditional testing methods of the telco and cloud industries. And finally, we'll explore, we'll explore the concept of the Mirror Lab as a way to reconcile these two worlds. I will tell you that there is going to be some audience participation coming, so be on your toes. And again, if you have any questions, please submit them using the Q&A function, and we'll do our best to answer them at the end. Anyway, let's get started. So there's a lot of talk in the wireless industry these days about the telco cloud and network virtualization. There's no question that regardless of the degree of virtualization in any given network, the typical mobile network is undoubtedly more complicated now than it was in previous generations. There are multiple possible network architectures and RAN splits, different architectures for different service types and quality of service, more frequency bands in use than ever before with different propagation characteristics, multiple radio access technologies in use simultaneously, and all to deliver an expanding list of innovative user services. This means combinations to test are expanding a lot. How can operators adapt their testing and deployment processes to manage this change? We'll try to answer that today, but before we can answer it effectively, we need to spend a few minutes looking at how things are generally done today. The operator community is no stranger to testing. A modern wireless network is a complicated thing and requires a great deal of effort to design, build, and maintain. Mobile network operators spend a great deal of time and money testing their networks and services to ensure that they meet their customers' expectations. One of the ways they do this is with an RF lab. When it comes to effective network and device testing, the first thing to recognize is that the end user is the ultimate tester. And their ultimate measure is their perception of the service as it is delivered to them. That in turn depends on the correct configuration and operation of the entire network. Many different elements must work together to deliver the experience, and it's the role of the operator to make sure that that all works. Each element of the network contributes to this performance, from the core, through the various CU/DU split possibilities, to the RRUs, the RF site design, the propagation characteristics of the RF channel, and the radio access technologies, and of course the user equipment itself. To validate the correct operation of all of this, the operator needs to perform many tests in a controlled environment before releasing a given configuration into the wild of the production world. We look at it from a commercial perspective. As wireless customers become more sophisticated, and the industry turns from subscriber growth to churn management, the need to deliver a solid customer experience has never been greater. The key question is, what's the right way to test to make sure that the best end user experience is delivered, given the trade-offs between time, cost, resources, and quality? That's not an easy question to answer, and there's a lot of different approaches. Many operators, labs rely simply on testing parts of the network in isolation. And this is useful for certain cases where problems can typically occur, like key interface points in the network. But it doesn't really represent the reality of the full service being delivered. Some operators rely heavily on emulation, which is also part of a reasonable testing approach. In essence, this is simply a UE talking to something pretending to be a network, or a network talking to something pretending to be a UE, or many UEs. But emulation, even when done at scale, doesn't reflect the actual real-world environment because there are too many things missing from the model. Still, other operators create a testing environment that mirrors the real world to really evaluate what the end user will experience. This approach uses real-world equipment to the largest extent possible. Real network cores, BBU and RRU equipment, the specific frequency assignments, carrier aggregation and MIMO designs, and actual user equipment. This obviously requires the most gear and human resources, but it results in the most accurate testing. So Sonia, I'm going to ask you for some help here. Let's pause for our first audience poll. I promised this. What testing tools do you typically see used in RF labs? And you can choose any. And so let's give this a few seconds here for people to cast their ballots. And then Sonia, maybe I'll get you to read out, tell us the top two. We have a clear winner?
So far, yes. We have, most people have voted for variable attenuators.
Okay.
Shortly followed after the network emulators.
Okay.
And those seems to be the one in the top two positions.
All right. That's kind of what we expected. So thank you, everybody. So now that we've talked about the equipment, here we go. Let's talk about the testing process itself. Regardless of the equipment that we use, the current practice for RAN testing looks something like this. Each test is generally independent and done to validate a set of proposed changes to an existing configuration. This might be something like a new version of base station firmware, or maybe something more significant like the addition of a new frequency or inter-RAT handover scenario. It may also be to help troubleshoot an issue in the field, like excessive drop calls or audio issues. Testers typically set up manually, which can take a long time, perhaps even hours or days, depending on the complexity. In fact, we've seen that the test setup and teardown times can often be far longer than the actual testing itself. After the testing is done and the test results evaluated by the engineers, the change is approved and okay for deployment. Then the process is repeated with more time invested in the changeover between tests. Each time at the end of the test, network engineering takes the results and deploys that change into the production network by making the same changes that they hope were tested in the lab. This is also done manually, perhaps with some scripting to eliminate some of the tedious data entry. The monitoring of the production network happens in parallel through the usual tools like OSS and BSS. Those measure key performance indicators, which are monitored and used to determine if there's any more changes that need to be made, which in turn results in more testing. The feedback loop is largely manual. This is very similar to the waterfall method of software development, where each release is developed, tested, and deployed sequentially, and the time between iterations can be quite long. This is perfectly fine in cases where the number of potential permutations is small and the rate of change is low. The telco world used to be like that, but it's changing. Telco networks are becoming more like IT networks for almost everything except the physical layer. The potential for virtualization of almost everything else means that there are vastly greater numbers of potential configurations, and the rate at which these configurations change is much faster. This leads to a huge increase in the number of possible scenarios to test, and a much shorter time frame in which to test them. Dean Brower, VP of Network and Field Operations at Verizon, said recently that the number and types of network nodes are growing exponentially. So the ability to both deploy and to manage that network at scale is crucial. He went on to say that he considers testing to be its own operational challenge in terms of how operators make sure they can meet the requirements that customers want to see in various 5G services. He said they had to be able to measure and monitor the network very well, real time at a scale that they haven't seen before. Now, Open RAN, the emergence of Open RAN complicates this even further. Prior to Open RAN, the operator could rely on their infrastructure vendor partner or partners to manage much of this complexity with purpose-built, highly integrated network architectures. With Open RAN, the operator becomes the integrator and is therefore responsible for ensuring that different vendors' hardware and software work together to deliver the service. Traditional MNOs may not have the skills necessary to handle this new reality, whether they're cloud computing skills or systems integration skills. To thrive and maybe even survive in this new reality, mobile operators will have to change how they test and deploy their networks. They will need new tools and new processes to do it. At Acentury, we think there are lessons to be learned from cloud-native companies who have already faced these challenges. In the world of IT, a practice known as DevOps is used to blur the lines between the roles of the development and operations functions to more effectively produce quality output. The idea is that the more closely these two groups are integrated, the more communications will be streamlined, and there will be less opportunity for mistakes and misunderstandings. Within DevOps, there's a related process known as continuous integration, continuous deployment, also known as CI/CD. The CI part refers to the automation of the creation and testing processes, while the CD part refers to the packaging and delivery of the end product. These concepts are very powerful, but are generally used in the cloud and IT worlds, where the product is software and therefore entirely virtual. How can they be applied to the world of wireless networks where there's very real bits of infrastructure? How can traditional mobile operators benefit from them? Time for audience participation. Point number 2, let's see how familiar people are with the concept of DevOps and CI/CD. Once again, we'll give a few seconds and Sonia can let us know where we are on that continuum.
So far, we have a clear winner. So far, about 60% or 56% of people have said that they are familiar with the concept but have never used it, followed by around 30% of people say they have some experience.
Okay, so no DevOps masters in the audience today. Okay, so for those who aren't as familiar with it, let's take a closer look at CI/CD and DevOps. In the software world, CI/CD bridges the gaps between development and operation activities by using automation in the building, testing, and deployment processes. CI/CD compiles the incremental changes made by developers and then links and packages them into deliverables. Automated tests verify the functionality, and automated deployment services deliver them to the end user. The aim is to increase early defect discovery, increase productivity, and provide faster release cycles. This process contrasts with traditional methods where a collection of updates are integrated into one large batch before being tested and deployed together in a new version. Modern day DevOps practices involve continuous development, shown here in the light blue, continuous testing, the darker blue, continuous integration, deployment, and monitoring of applications, shown in the yellow. Taken together, the practice encompasses the entire development lifecycle. Some of the benefits of DevOps are the following. First, organizations that use it have clearly seen quality improvements, significant quality improvements. This results from a few things. The testing regimen is much stronger and catches more defects. And the short cycle times between releases means that any escaping defects are fixed more quickly. But the real advantage is the close collaboration between the development and operations functions. There's just fewer opportunities to screw up when people work closely together. The continuous nature of the process means that the development and deployment cycle time is much faster. Cloud native companies are able to release new versions daily perhaps even more often. You might think that the continuous nature of the process would lead to chaos, but actually the opposite is true. The regular test and release cycle creates a stable environment because it's so regular. The organization doesn't veer anymore from guardrail to guardrail as people panic when release dates approach. The automation of the more mundane tasks leaves more time for value-added work. All the smart engineers you have on your staff can focus their time on innovation instead of manually running test scripts. And finally, it helps to breed a greater sense of agility across the organization. Companies that work this way become more customer responsive, and that's a good thing in a competitive world like wireless. So it's clear that DevOps is a useful approach to launching products in the software world, but how can we apply this concept to testing and deployment of things that are not virtual? How does it apply to testing and deploying 5G RAN? The 5G core and upper layers of the RAN can be virtualized, and by that I mean turned into software running on a server somewhere. So the DevOps concept applies well there. But what about the rest? Physical things like RRUs and the mobile device at the other end. The mobile network also includes the physical medium of RF, which can be used in different ways with RF engineering techniques such as MIMO and carrier aggregation to improve coverage and bandwidth. These are essential to delivering the service to the paying customer. How can we bring these parts of the system into the cycle of rapid testing and automatic deployment? This adaptation of the CI/CD diagram from the previous slides shows how we can think about these parts. There are parallel activities in the physical testing world that match those in the virtual software world. Here, the light blue shows the physical equivalent of the software development activities, and the dark blue shows the physical testing activities. So the CI/CD model can fit, but we aren't quite there yet. To be truly CI/CD, all this must be automated. Again, this is relatively straightforward when dealing with the virtual or cloud-based parts of the network, but the physical elements are a different matter. There are existing tools like OSS, BSS, and so on, shown here in the yellow, that can provide the real-world performance data for the feedback loop, but the rest of the CI/CD loop needs automation tools. And the two missing pieces now are shown in the dark blue here, a tool that can tie all the elements in the lab together to automate the test setup, execution, and analysis of the results. And shown in the dark red, a link to the production environment for automated deployment and recall. To address this need for our operator and equipment customers, Acentury applies a concept we think of as the mirror lab. The mirror lab is just what it sounds like, a reflection of the production network in the lab environment. The same equipment configured the same way. This means that any testing done in the lab is directly applicable to the production environment. A properly equipped mirror lab includes an orchestration layer to manage and control the testing, setup, execution, and test result evaluation processes, and the associated lab resources, both equipment and people. But that's not quite it yet. The other essential part of a complete mirror lab is a link to the production network to enable a deployment mechanism for automatic rollout of any validated changes. Once all the automated testing is complete and the results are deemed to have passed, the orchestration layer releases the validated configuration up to the production network where it's automatically deployed. This final piece integrates the testing and deployment processes into one system workflow and completes the CI/CD framework for the RAN and the mirror lab. In summary, the mirror lab blends the lab and production environments together, isolating them for test and integrating them for deployment. In this way, it models the real world. The subscriber device sees in the lab what it will see in the field. It enables more sophisticated test scenarios like roaming and handover, but with the actual radio access technologies, frequency bands, vendor equipment, and RF site designs that exist in the field, including specific MIMO and carrier aggregation configurations. Voice, data, video calls, messaging can all be validated in near real-world conditions. A mirror lab allows for the optimal use of test resources as well, whether those are physical equipment like RRUs, software containers running various network functions, or even people. Since everything is coordinated and tasks are automated, it's efficiently shared and there's no wasted time caused by resource blocking. The automation aspect reduces the time to market because testing is much quicker. Specifically, the test setup and teardown times are reduced from days to hours and hours to minutes. The tests themselves can be run faster, more consistently, and more often by software than any human could ever execute them. The tests are perfectly repeatable thousands of times in a way that isn't possible manually. So the confidence in the result is also much higher. The automation of the deployment function takes the more time-consuming manual steps out of that practice as well. And there's a much reduced opportunity for human error in the deployment process. The odds of a mismatch between lab and production become virtually zero. Time for another audience poll. We've implied some of the pain points that lab managers see on a daily basis. Let's see how common some of them are. We'll give again a few seconds for people to weigh in here. What do you see, Sonia? What are the biggest pain points?
Let's see here. Biggest pain point so far, still streaming in. I'm seeing the top two are the lengthy test setup, the tracing and rerouting of RF cables, and test equipment configuration. Seems to be a big one. Shortly followed by, oh, still streaming in. The sharing limited test resources and equipment. It's about 50% of people.
Okay. Okay, again, not unexpected based on our experience in the business. So thank you all. Now let's take a few minutes to look at the elements of a mirror lab. We'll examine each of these in more detail in a moment, but here's a quick summary. First one is end-to-end network, and this is to accurately mirror the production environment. Of course, it can be a subset of the production environment, but it should be a representative one, such as every combination of RRU vendor and frequency allocation. The orchestration layer. This is a key feature of the mirror lab. This layer controls and coordinates all the equipment and resources in the lab. Network equipment, RF switch matrices, variable attenuators, devices under test, signal analyzers, emulators. The orchestration layer ensures all of these work together seamlessly to test and deploy. Test automation, the ability to run tests and collect logs at scale with limited human involvement, is a key element of the CI/CD process. The deployment automation, the ability to copy a successfully tested configuration from the test environment to the production environment, is what differentiates this approach from other testing concepts. This saves time and minimizes the chances of production being out of sync with the lab. So let's look at each one in a little bit more detail. We'll start with the end-to-end network aspect. The concept here is simple. Use your own network to test your network. Use actual RAN and actual subscriber equipment because this is the best way to understand what will really happen in the wild. By all means, include some emulation as well. There's always a place for that. But focus on end-to-end testing of the real thing as much as possible. In this diagram, the lab below the red line contains everything that exists in the real world above the line. The actual RAN equipment, including RRUs on every frequency and whatever CU/DU splits are used, is all set up. The end user devices are contained in Faraday cages, which can be anything from a small desktop shield enclosure to a full-size walk-in anechoic chamber, depending on what you're trying to validate. The RF channel is recreated using a software-controlled RF switch matrix. This device takes a series of independent RF inputs from the RRUs or signal generators or whatever, and can mix them in any combination and send them to any combination of outputs. In this way, a finite set of resources, which we know is a problem from our last quiz, can be shared by multiple testers simultaneously. By combining them together, it can replicate various MIMO and carrier aggregation configurations And by varying the attenuation for each signal path under software control, it also replicates conditions such as handovers and roaming. Again, the user equipment sees what it would see in the real world. Now let's zoom in on the elements in the Mirror Lab to show the orchestration layer. It does several things, but we'll focus on two here for the moment. First, the lab manager uses it to configure, control, and coordinate all the resources in the Mirror Lab, from the CUD, RU, or signal generators, user equipment, and of course the RF switch matrix, which recreates the RF environment. Second, the lab manager uses it to share resources among multiple testers. Here, tester number 1 in yellow is assigned a portion of the RAN equipment, used, including 6 RRUs and associated CUD resources, and 1 RF shield box with a device under test. Tester number 2 in green is assigned their own RF shield box with a different device under test, and 4 RRUs and CUD resources, including some that are shared with tester number 1. Of course, this is just an example. You can have as many RF sources and as many testing stations as you need. The Mirror Lab can effectively share resources among multiple testers simultaneously. And those testers can even be in different places, a different room, a different building, or even a different city. To facilitate test automation, each resource in the system is controlled by the orchestration layer and configured according to the scenario being tested. Here we are showing the higher levels of the RAN, the CUD splits, the RRUs, and the devices under test, but it could also include signal generators and emulators. The RAN is configured just like the production network, and the devices under test are set up to make different call types, voice, data, video, messaging, etc., as required by the test plans. Next, the orchestration layer controls the RF switch matrix to execute the tests without human involvement. The various call types are automatically started on the device under test, and the RAN equipment is broadcasting signals into the RF switch matrix. By controlling the RF switch matrix, the various call types are made under different RF scenarios, like roaming, handover, with different orders of MIMO and carrier aggregation. Changing which signals are combined together duplicates MIMO and carrier aggregation, and changing the attenuation of the signal paths mimics handover between sites and roaming. These can be perfectly repeated as many times as necessary, and each test is just like the previous ones. Once the tests have been completed and passed, the orchestration layer sends the validated configuration to the production network via an API. This closes the CI/CD loop so the process can begin again. It saves the effort and time of manually uploading the new configuration and reduces the opportunity for human error. If there are multiple infrastructure vendors, obviously an API for each vendor would be required. Another key benefit of this API link to the production environment is that configurations can be recalled from the real world to the lab for further testing. Let's say there are trouble tickets for drop calls in a certain geography. The network configuration from that area can be recalled and automatically set up in the lab for evaluation. Hundreds or even thousands of regressions can be run to reproduce and root cause any issues. One of my favorite side benefits of an implementation like this is that the lab gets a lot more organized. Typically, RF test engineers need to continually trace RF signal paths through patch panels like the one on the left here, and reroute them through a variety of splitters to feed different test chambers. The result is a constantly changing test environment, so test reproducibility is difficult, if not impossible. And honestly, it's messy. With an automated Mirror Lab, there's no need to keep tracing and rerouting cables. Cable everything up once and lock the doors, and the automation system can handle the rest. Okay, audience poll number 4. This one's a quiz to see if you were paying attention. So let's see how many of us get this right. So choice 1, a Mirror Lab saves time through test and deployment automation. 2, one of the benefits of a Mirror Lab is that it keeps the testing and deployment functions separate. 3, DevOps and CI/CD can be applied to RAN testing. The Telco cloud migration will force mobile network operators to change their testing and deployment processes, or the orchestration and management layer coordinates and controls all the resources in the Mirror Lab. How are we doing?
Pretty well, I would say.
Okay.
About 60% got answer number 2.
That's right.
Yeah, which is the correct answer.
Correct answer. So the rest of you can watch the recording of the webinar for review. Move on. When we come across the need for a Mirror Lab at Acentury, we use our Lambda solution. It's used by multiple operators and equipment vendors to run their RF testing operations. Lambda is an orchestration platform that applies the concept of DevOps or CI/CD to the testing and deployment of the 5G RAN. It enables end-to-end testing of the entire system using a combination of RAN, devices under test, emulation. It allows lab resources to be shared among multiple users simultaneously, and those users can even be in different locations. And it provides a management platform to plan and track testing activities. It also provides the automation platform. Test setup takes minutes instead of hours or even days, and testing can be done quickly and repeated hundreds or even thousands of times. Since there's no human involvement in the testing, the tests themselves are perfectly repeatable, which means higher confidence in the results. Now, once the testing is complete, Lambda can deploy the validated configuration directly to the production network, closing the CI/CD loop. This eliminates a lot of tedious manual work, reduces the chance of human error, and the chance that production doesn't match what was validated. In a sentence, Lambda integrates the lab and production environments together to allow seamless testing and deployment as part of the same system workflow. It enables faster and more sophisticated testing and rapid deployment at scale. With that, I think we'll move to our questions. I think there's been some activity in the Q&A. So let's see, Sonia, have you had a chance to read through them? And what have you got?
We have a few here, and feel free to keep asking questions in the QA box below. First one I see here is, I already have test automation in my RF lab. Why do I need a Mirror Lab?
It's a good question. And test automation is probably automating part of the end-to-end process. And that equipment can be rolled into the Mirror Lab. The Mirror Lab you can think of more as an organizational structure that controls the various assets that you have, whether it's existing test automation, variable attenuators, vector network analyzers, or people, and organizes them in a way that they become more efficient. So yes, you've already got it. That's great. That's a great start. The orchestration layer of a Mirror Lab ties all of those resources together to provide end-to-end testing.
Okay, great, thank you. Another question we have here is, can I reuse equipment in a Mirror Lab, or do I have to start over?
Absolutely, you can reuse it. It's the concept of the Mirror Lab is to tie all those resources together. In the case of Lambda, for example, our solution, we already have interfaces to several of the vendors that you might expect to find in a lab, various network equipment vendors, RF switch matrices, and basically we're architected in such a way that any device that has an API, we can integrate into that solution. So absolutely, yes, you can maintain the investment that you have in your current testing assets. Any shield boxes or RF chambers, most variable attenuators, programmable variable attenuators, switch matrices, obviously network equipment, all can be reused.
Thank you. Another question we have here. We already have a CI/CD tool. Why can't we just use that?
That's good news. I'm glad that some people have adopted CI/CD. That's a great start. CI/CD it started life as a software tool for software development. So I'm going to I'm going to assume that it doesn't necessarily have the ability to incorporate the physical parts of the network that exist in a wireless network. But any CI/CD tool you currently use for the software portions can obviously form part of the function of a Mirror Lab. A system like Lambda or the Mirror Lab concept that we've talked about here today really is talking about integrating the physical assets of a wireless network with the virtual assets of the new type of architecture, so they can all be tested and deployed together.
Okay, we have another question here. What are the challenges bringing in different vendors to come together for CI?
The principal challenge is, having, from our perspective anyway, as a supplier of one of these types of solutions, is to have access to the APIs necessary to control those elements in the system. As I said, we have interfaces already developed for several of the recognizable names, and we would easily be able to accommodate others if there were other vendors' equipment that we hadn't already integrated with. We're absolutely willing to do that. Sometimes we require our operator customers to help broker those initial relationships, but we haven't really had any difficulty doing it.
Alrighty, and I think we have just one more question here. Do we have any benchmarks that we might have based on some of the runs done in the done in the Mirror Lab?
Probably none that I should share. Obviously, we treat our customer relationships with great care. I will say anecdotally, one of my favorite quotes from a customer was something to the effect of, "I love this system. I was able to do 45 handover tests while drinking my tea." And I think that sort of says a lot about the power of a system like this. They were able to set it up and click a couple of buttons, and the tests all ran, and it freed them up to do something else. These are highly expensive human resources that can be, rather than have them executing test scripts or manually controlling variable attenuators, they can be doing something more valuable.
Okay, thank you. Another question here. Can Lambda scale to orchestrate a lab similar to ours with upwards of 800 RRH, 10 full-size anechoic chambers, upwards of 20 4G and 5G core instances, and 20 shielded rooms?
The answer is yes. So the costs of a Lambda implementation vary by two things. One is the number of radio inputs that you have, so 800 inputs to one side of the system, and to a lesser degree, it varies based on the cost of the number of outputs to shield boxes or test stations. There's a number of strategies to combine the 800 radio ports into a single input or into a fewer number of inputs on an RF switch matrix. But really, there's no limit to the number of switch matrices and input ports that a Lambda system can support. There's some practical design limitations there in terms of the bigger the switch, the more insertion loss there is. So we would probably use more switches of smaller size, and Lambda would integrate them together, and they would appear as a virtual switch of that size. So the answer is yes, it'll support a lab that size. We have customers now with hundreds of radios set over multiple city sites, and all those resources are shared. So absolutely, we can. That shouldn't be a problem. It would be a significant installation, but operationally, it will work.
Thank you. Now, how do you handle different IPRs with a mix of vendor solutions in ORAN with 5G core and SA? Or do they have to be separate tenants?
This is it's a good question. This is an on-prem solution largely. So basically the software resides on a server, in Lambda's case anyway, the software resides on a server that is resident within the carrier or the operator or equipment vendor lab on their internal network. So there's no There's no data outside the organization, outside those firewalls. We sometimes have an access for routine diagnostics and maintenance, but all that is done within the operator network generally. So we would use their data security and their intellectual property right management system to manage those relationships. So yeah, there's nothing that leaves the customer prem for a LAMP installation generally. I hope that answered the question. I think I did, but if not, you can reach out to me after and I'll try to clear that up.
Okay, and right now that's all the questions that we have. So.
Okay. With that, if anybody was too shy to ask questions in a forum like this, here's my contact information. I'd be pleased to speak with you. I look forward to it. So I'll leave that up here. That's our website as well. And with that, I'll close off. Thank you very much for your time and your attention today. Have a great day.
Thanks, guys. Take care.